Hi, good evening everyone. This is Shefali Singla, and in this session we are going to discuss the previous year questions from 2020. Already हम पिछले 2-3 सेशन से questions discuss कर रहे हैं. In today's session, we'll be majorly covering the questions from computer organization and architecture, theory of computation, and compiler design. Okay. Although mix करके questions लें किसी एक particular subject के नहीं लें, but in the last session we had the major questions from operating system. बीच में कुछ कंप्यूटर नेटवर्क्स और दूसरे क्वेश्चंस भी आए थे. उससे पहले वाले सेशन में हमने डिजिटल और डीबीएमएस की किए थे. सो आई गेस वी आर लेफ्ट विद दीज सब्जेक्ट्स. सो लेट्स स्टार्ट विद द क्वेश्चंस. हर क्वेश्चन को रीड करने के लिए, अंडरस्टैंड करने के लिए, ट्राई करने के लिए आई विल बी गिविंग यू 1 minute and you just have to try to understand the question. कोशिश करके देखो कि अगर आप उसको सॉल्व कर पाते हो. अगर कोई डाउट आता है तो डायरेक्टली you can write that in the chat section. Okay, so this is the first question from the computer organization and architecture और आपका favorite topic pipelining. सो आपको मालूम है कि जब भी हम कंप्यूटर ऑर्गेनाइजेशन आर्किटेक्चर की बात करते हैं, सबसे इंपॉर्टेंट टॉपिक क्या है, तो सबसे पहली चीज आती है पाइपलाइनिंग. सो दिस इज द क्वेश्चन फ्रॉम पाइपलाइनिंग. इस क्वेश्चन में आपको स्पीड अप रेशियो कैलकुलेट करनी है बिटवीन द पाइपलाइन एंड द नॉन पाइपलाइन सिस्टम. ओके, यहाँ पे कुछ एक्स्ट्रा स्टॉल्स भी क्रिएट हो रही हैं. दैट इज एवरी 5 साइकिल्स अ बबल ड्यू टू अ डेटा हैजार्ड हैज टू बी इंट्रोड्यूस्ड इन द पाइपलाइन. क्या करोगे आप? टाइम कैलकुलेट करोगे दैट इज रिक्वायर्ड विद द पाइपलाइन सिस्टम एंड विदाउट पाइपलाइन. उसके बाद स्पीड अप रेशियो कैलकुलेट करेंगे. डू यू वांट टू ट्राई दिस क्वेश्चन? Consider a 5 segment pipeline. Number of segments are 5. Number of instructions are given as 100, and each cycle requires 20 nanoseconds. I guess without pipeline it's very easy to calculate. So time required without pipeline. एक इंस्ट्रक्शन को एग्जीक्यूट करने के लिए कितना टाइम चाहिए? हर स्टेज से होके जाएगी. 5 stages are there. Time required for each cycle is 20 nanoseconds. This comes out to be for one instruction. But here we are given with 100 instructions, so we'll multiply it with 100. So this comes out to be 10 and you can just keep this as it is. और अगर आपको फॉर्मूला लेना है तो मैंने यहाँ पे वैल्यू सब्स्टिट्यूट किए. दिस इज नंबर ऑफ सेगमेंट्स. कितने सेगमेंट्स है, हर एक ऑपरेशन के लिए कितना टाइम चाहिए, दैट इज क्लॉक साइकिल per stage, and how many instructions are there into number of instructions. Very good evening, Prashant. Number of instructions. So this will give you the time required without pipeline. Now with pipeline, time required with pipeline. Although formula करवाया हुआ है, but formula use करने की आपको जरूरत नहीं है. You can understand this. जो पहली इंस्ट्रक्शन आएगी उसको पूरी 5 स्टेजेस चाहिए क्योंकि उसमें कोई ओवरलैपिंग नहीं हो रही है. बट फॉर द रिमेनिंग स्टेजेस, हर स्टेज पे आपको एक इंस्ट्रक्शन के लिए आउटपुट मिल जाएगी. टोटल 100 इंस्ट्रक्शंस आर देयर. सो इन एडिशन टू 5 clock cycles, after 5 clock cycles you will be getting the output for the first instruction, and after that from every instruction will be getting the output. So there are remaining 99 इंस्ट्रक्शन. 100 में से एक तो निकल गया क्योंकि उसके लिए हमने 5 स्टेजेस काउंट कर लिए. सो प्लस 99, and each instruction requires 20 nanoseconds of time. In addition to this, if we calculate the extra time is required, that is in the form of the hazards or the stalls. कितना टाइम बोला है यहाँ पे? If an average every 5 cycles, मतलब हर 5 साइकिल्स के बाद एक स्टॉल क्रिएट हो रहा है. दैट मीन्स टोटल स्टॉल्स कितने क्रिएट होंगे? टोटल स्टॉल्स क्रिएटेड will be total 100 instructions है, और after every 5 instruction one stall is created. That means 20 extra cycles. Stalls are nothing but these are the extra cycles. एक्स्ट्रा साइकिल्स। तो इतने साइकिल्स हमें इंस्ट्रक्शन के लिए चाहिए थे, प्लस in addition to this 20 extra cycles are required and clock cycle time is given as 20 nanoseconds. This is also the nanoseconds. इतना क्लियर हुआ? अब हमें फाइंड करना है स्पीड अप रेशियो, सो राइट द फॉर्मूला फॉर द स्पीड अप रेशियो। किसकी स्पीड अप रेशियो कैलकुलेट करनी है? स्पीड अप रेशियो बिटवीन द पाइपलाइन एंड द नॉन पाइपलाइन प्रोसेसर। सो दिस कम्स आउट टू बी without pipeline divided by with pipeline how much time is required. Everything is in nanoseconds, so कोई problem ही नहीं है with pipeline. Just substitute the value, so this comes out to be 5 into 20 into 100 nanoseconds, and here we have 5 plus 99 plus 20 into 20 nanoseconds into 20 nanoseconds. So 20 से 20 nanoseconds तो cancel हो गया. So can you tell me that what speed up ratio you are getting? Nanoseconds से nanoseconds cancel हो गए, 20 से 20 cancel हो गया. So ultimately we are getting here 500 divided by, this is 124. So what answer you guys are getting? I hope this is clear now. So it is somewhere around 4.03. So the answer for this question is it's 4.03. Is this clear? I guess this was a very simple question. सिर्फ एक ही चीज आपको यहाँ पे ध्यान में देनी थी कि ये इस लाइन का क्या मतलब है, एक्स्ट्रा साइकिल्स का क्या करना है. So in the pipeline some extra cycles are coming up. Otherwise straightforward speed up के basis पे हमने बहुत सारे questions किए हैं. Pipeline और without pipeline time कैसे calculate करते हैं, that also we have covered. The only thing was here the extra stalls were introduced. Make sense? Guys, is this clear? So this is the first question from today's session, and that was from pipelining. I guess this was a good question. इस type के questions GATE में भी बहुत आते हैं. Speed up और pipeline के basis पे GATE, अगर previous year GATE papers उठा के देखोगे तो उसमें आपको काफी सारे questions मिल जाएंगे. Quickly give me the confirmation if it's clear. Then I'll move on to the next question. Okay, this is also from the computer organization and architecture. ये question कौन से topic से? This is from the instruction set. Here you are given with a 32-bit processor which supports some instructions and there are 4 fields. जब भी आपको fields और इस तरीके का कुछ given हो, मैंने आपको बताया कि diagram बना लो और जो value given है उसको लिख लो. What is stall? I have written over the slide here. This is some extra cycles required. जब कोई दो इंस्ट्रक्शंस के बीच में डिपेंडेंसी होती है, फॉर एग्जांपल इंस्ट्रक्शन 2 को कुछ ऐसा डेटा चाहिए जो इंस्ट्रक्शन 1 राइट करेगा. अब मान लो इंस्ट्रक्शन 1 को राइट करने में थोड़ा ज्यादा टाइम लग गया, तो इंस्ट्रक्शन 2 इज डिपेंडेंट ऑन इंस्ट्रक्शन 1, सो इट हैज टू वेट. तो वो जो वेट करने के लिए साइकिल को मिस करेगा, दैट इज द एक्स्ट्रा साइकिल, दैट इज द स्टॉल. ओके, तो ये डिपेंडेंसी काफी वजह से हो सकती है. डेटा डिपेंडेंसी हो सकती है, रिसोर्स डिपेंडेंसी हो सकती है. फॉर एग्जांपल दो इंस्ट्रक्शंस है, दोनों को एग्जीक्यूट करना है, बोथ वांट्स टू एग्जीक्यूट अंडर द सेम स्टेज, तो वहां पे एक इंस्ट्रक्शन को वेट करना पड़ेगा. सो जब वेट करते हैं तो एक्स्ट्रा साइकिल इंट्रोड्यूस होता है, उसको बोलते हैं स्टॉल. वेरी गुड इवनिंग शुभम. I hope this is clear to everyone. Next one is also from the COA, and in this you are given with the instruction. It's a 32-bit processor which supports some number of instructions are given to you, and each instruction is size of each instruction is given to you, and 4 fields are given. तो क्या करना है इस टाइप के क्वेश्चन में, जब भी इस तरीके का कोई स्ट्रक्चर गिवन हो तो सबसे पहले हम एक डायग्राम बना लेंगे, सो दैट हमें पता चले कि चाहिए क्या और क्या गिवन है एंड व्हाट वी आर supposed to find out. So here we are given with the instruction which is having 4 fields, and the name of these fields are opcode, that is the operation code. कितनी instructions है, हर instruction को uniquely identify करने के लिए कुछ code required है, तो आप opcode की bits calculate कर सकते हो. 2 register identifiers are required, register 1 and register 2. After that, immediate operand is required, so this is immediate operand. Total size is given as 32 bit. Make sense? Now find out what will be the bits required to represent the opcode. We are given that 70 instructions, so this information will give you the number of bits required for the opcode. अगर 70 instructions है, हर instruction को uniquely identify करना है, तो कितनी bits चाहिए? Simply we have to अगर आपको total combinations find करने होते हैं तो आप 2 raised to power कर लेते हो, यहाँ पे already 2 raised to power है, so we'll be taking its log, so it comes out to be log 70. bit की value 2 हो सकती है, base 2, and obviously this is greater than 6. Value comes out to be greater than 6 because 2 raised to power 6 is 64, so value is greater than 64 but less than 2 raised to power 7, that is 128, so it will be somewhere around 6 point something. Now next point is, do we need to consider here the seal value or the flow value? अब सोच के देखो कि 6 बिट्स के साथ आप 64 combinations represent कर सकते हो. Maximum number of combinations that can be represented with 6 bits is 64. But here we want to represent 70 instructions. This means that more than 6 bits are required. So I'll be taking here the seal value. What is the seal of log 70? That comes out to be 7. This means that 7 bits are required by the opcode. Each instruction is 32 bit long and we have read this instruction. Now maximum value of the immediate operand that can be supported by the processor is, maximum value immediate operand की क्या represent कर सकते हैं? 8191. This means that this will give you the number of bits required for the immediate operand. Immediate operand के लिए कितनी bits चाहिए? मैक्सिमम वैल्यू जो रिप्रेजेंट करनी है दैट इज 8191, तो इस वैल्यू को रिप्रेजेंट करने के लिए हाउ मेनी बिट्स आर रिक्वायर्ड? इन ऑर्डर टू कैलकुलेट दैट विल टेक द लॉग ऑफ दिस वैल्यू 8191, and obviously here also we'll be taking the seal value. Reason is the same, so this comes out to be it's somewhere around 13. So 13 bits are required by the operand field. अब रजिस्टर्स के लिए कितनी बिट्स रह गई? रिमेनिंग बिट्स आर, remaining bits will be, total bits were 32, जिनमें से 7 bits opcode ने ले ली, 13 bits operand immediate operand ने ले ली, remaining are 12. 12 bits will be used by the registers. So there are 2 registers, so number of bits required by each register, number of bits required by each register, हर एक रजिस्टर के लिए कितनी बिट्स चाहिए होंगे? दोनों के लिए टोटल बिट्स आपके पास जो रिमेनिंग बिट्स आएंगे दोज आर 12 बिट्स. तो एक रजिस्टर के लिए कितनी चाहिए? सिंपली आई विल डिवाइड दिस बाय 2, सो 12 डिवाइडेड बाय 2 bits, this comes out to be 6 bits. Now they are saying that how many registers the processor has. एक रजिस्टर को रिप्रेजेंट करने के लिए 6 बिट्स चाहिए, तो 6 एक रजिस्टर को रिप्रेजेंट करने के लिए 6 बिट्स चाहिए. So with 6 bits how many registers are possible? So obviously it will be or in simple terms, how many combinations are possible? 6 bits, it's 2 raised to power 16. So number of registers will be 2 raised to power 6, that is nothing but 64. So this is what was asked in the question. So correct answer for this question is 64. Simple. बट डेफिनेटली जो लोग ऐसे इंस्ट्रक्शन बना के आइडेंटिफाई नहीं करेंगे, दे मे गेट कंफ्यूज्ड और दे मे नॉट गेट द आइडिया व्हाट यू आर सपोज्ड टू डू. अब यहाँ पे हर चीज आपको जो गिवन थी, हमने देखा कि भाई ये फील्ड्स चाहिए, ये वैल्यूज गिवन है और जो बचे उसको फाइंड आउट करिए. I guess you guys are not comfortable with the concepts of the COA because no one is returning the answer. Anyways, next one, the immediate addressing mode. This is again from the computer organization and architecture. The immediate addressing mode can be used for, immediate addressing mode क्यों use करते हैं, कहाँ use करते हैं? Is it used for loading the internal registers with the initial values? Opcode means instructions. Yes, जैसे आपके पास opcode आता है, add is one opcode, multiplication MUL is one opcode, SUB that is the opcode for performing the subtraction operation, MUL is the opcode for performing the multiplication operation, ADD is the opcode for performing the addition operation, MOV that is the opcode for moving the data from one location to the other location. So these all are the opcodes. Okay. Next one, the immediate addressing mode can be used for, immediate addressing mode is used for what purpose? No calculation is required. It's just asking on the basis of, this is the question from the topic, that is addressing modes. जब मैंने addressing modes करवाए थे तब भी आपको बताया था कि addressing modes are very important. Addressing modes और equation pipelining का आना ही होता है, equation cache memory का भी आना ही होता है. I guess cache memory वाला question जो ISRO 20 में आया था वो हम लोगों ने कल वाले session में cover कर लिए. Am I right? Only 2 is the answer. क्या immediate addressing mode सिर्फ और सिर्फ arithmetic और logical operation के लिए use करते? Can't you use this immediate addressing mode for loading the registers? We can do that. So it's used for performing both the operations, that is loading the internal registers with the initial values and performing the arithmetic or logical operations. ये दोनों चीजें मैंने examples लेके we had discussed that in detail under the addressing modes topic. So this was clearly a straightforward question. Answer for this question is it's option C. Next one. Statements associated with registers of a CPU are given. This is again from the computer organization and architecture. Identify the false statement. Which of the statement is false from the given instructions? We have addressing mode for that, ma'am. See, addressing mode is one topic under which we have lot many addressing modes. Yes? We have immediate addressing mode, we have direct addressing mode, we have indirect addressing mode, and so on. Addressing mode तो एक topic है. There are few operations which can be supported by various instructions. कभी भी ऐसा नहीं होता है कि यूनिक होता है. जो एड्रेसिंग मोड्स है अगर हम उनकी क्लासिफिकेशन करते हैं, देयर आर टू ब्रॉड क्लासिफिकेशंस ऑफ द एड्रेसिंग मोड्स बेस्ड ऑन रजिस्टर्स, एड्रेसिंग मोड्स बेस्ड ऑन मेमोरी. बेसिकली एड्रेसिंग मोड का मतलब क्या होता है? जो आपके पास डेटा है, डेटा कैन बी अवेलेबल इन द रजिस्टर और मेमोरी, राइट? अगर हम इंस्ट्रक्शंस की बात करते हैं, इंस्ट्रक्शंस आर ओनली अवेलेबल इन द मेमोरी, तो इंस्ट्रक्शन के लिए आज सच कोई एड्रेसिंग मोड नहीं है, बट data can be available in the registers or in the memory. So that's why the addressing modes were divided into the two categories. When the data is available in the register, so those are the register based addressing modes, and if the data is available in the memory, so for that we need the memory based addressing modes. Okay, तो एड्रेसिंग मोड सिर्फ रजिस्टर एड्रेसिंग मोड नहीं है. इसका मतलब आप इस स्टेटमेंट से डिनाई कर रहे हो कि डेटा मेमोरी में नहीं हो सकता, which is totally incorrect. Okay, A is false for this question. Yes, that's true. Program counter holds the memory address of the instruction in execution. प्रशांत, मैंने आपको ओवरव्यू दे दिया एड्रेसिंग मोड्स का कि हमारे पास जो एड्रेसिंग मोड्स डिवाइड हुए हैं वो किस बेसिस पे और कैसे डिवाइड हुए हैं. आई गेस यू नीड टू गो थ्रू द सेशन और यू नीड टू गो थ्रू द कॉन्सेप्ट अगेन. So if you are saying we have the register addressing mode, I'm not denying कि register addressing modes नहीं होते हैं, बिल्कुल होते हैं, but still we have lot many classifications. Reason I hope it's clear. All right, so here we just have to find out that which statement is false. So program counter holds the memory address of the instruction in execution. You guys are saying this statement is false. Then what is the true statement? तो program counter क्या hold करते हैं? Program counter क्या hold करते हैं? Program counter holds the memory of programs. True statement is program counter. What is the functionality of program counter, guys? Very good, Pradeep. It holds the program counter holds the memory address. Instructions are only present in the memory. There is only one possible location. Memory address of the next instruction. This is the next instruction. But यहाँ पे क्या given है? Current instruction का address hold करते हैं. That statement is incorrect. It holds the address of the next instruction to be executed. So definitely this statement is false. The opcode is transferred between the control unit. बिल्कुल control unit के साथ transfer होता है. That's why on the basis of the opcode it is going to access the data. कहाँ से data लेना है, क्या data आएगा? It depends on the opcode itself. तो decoding होती है. We had when I constructed the diagram, I used that decoder क्योंकि अभी हमने instruction में देखा जो आपके पास opcode आ रहा है that is in the coded format. So in order to understand that what operation it has to perform, need to perform the decoding. So this statement is true. An instruction in the instruction register consists of the opcode and the operand. बिल्कुल हो सकता है, opcode भी हो सकता है, operand भी होता है. The value of the program counter is incremented by 1. जैसे ही instruction fetch होती है, instruction fetch में दो operations perform होते हैं. On the basis of the very first step is on the basis of the program counter value, it is going to fetch the instruction. As soon as it fetches the instruction, it immediately increments the value of the program counter in order to point to the next instruction to be executed. So once its value has been read, the memory address register. So this statement is also true. So undoubtedly, वैसे भी ISRO में सिर्फ और सिर्फ MCQ क्वेश्चंस आते हैं जब आपको पहली स्टेटमेंट को लेकर आपको कॉन्फिडेंस है कि भाई यही स्टेटमेंट गलत है, तो you need not to waste your time in finding out the other or reading the other instructions. All right. This is again from the computer organized. By any chance, सारे लगातार computer organization architecture के आ रहे हैं. Don't worry, I'll be taking the questions from theory of computation and compiler design as well. So, which of the following affects the processing part, assuming they do not influence each other? Which of the following affects the processing part, assuming they do not influence each other? किससे प्रोसेसिंग फास्ट होगी और किसका अफेक्ट प्रोसेसिंग पार्ट पे पड़ता है? डेटा बस कैपेबिलिटी, विल इट अफेक्ट द प्रोसेसिंग पार्ट? Addressing scheme, will it affect the processing part? Clock speed, will it affect the processing part? This is what you are supposed to return. So what should be the answer? 3 only. It's only the clock speed. Data bus capability का कोई फर्क नहीं पड़ेगा. क्लॉक स्पीड तो ये बता रही है कितने साइकिल्स पर सेकंड आप एग्जीक्यूट कर रहे हो, तो जितने साइकिल्स पर सेकंड एग्जीक्यूट होंगे ऑब्वियसली फास्टर विल बी द ऑपरेशन, राइट? सो मोर साइकिल्स पर सेकंड, जितने फास्ट it will work, it means that it implies faster is the operation. So definitely this will be included in the result. What about instruction 1, data bus capability? Will it affect? जितनी ज्यादा डेटा बस की कैपेबिलिटी होगी उतना ज्यादा डेटा इट कैन होल्ड, तो नंबर ऑफ क्लॉक साइकिल्स रिक्वायर्ड विल बी लेस. फॉर एग्जांपल, आपको 100 बाइट्स का डेटा ट्रांसफर करना है, एक बार में आप सिर्फ 5 बाइट्स का डेटा लेके जा रहे हो, 20 क्लॉक साइकिल्स आर रिक्वायर्ड. बट अगर डेटा बस का साइज इंक्रीज कर देते हैं कि एक ही बार में 10 बाइट्स जा रही है, तो ऑब्वियसली नंबर ऑफ क्लॉक साइकिल्स विल रिड्यूस एंड हेंस इट विल अफेक्ट द प्रोसेसिंग पार्ट. मेक सेंस? So this means that larger will be the data bus larger will be the data bus, it implies bigger operand. Operand means the data can be transferred, resulting into less number of clock cycles. तो डेटा बस का भी अफेक्ट हो रहा है. Data bus also affects that. So this is also true. What about the addressing scheme? Will it affect? I hope आपको समझ में आ गया कैसे इसको प्रोसेस करने. Address larger है, smaller है, will it affect or not? तो obviously 3 only is not the correct one. 2 भी correct है तो B भी बाहर हो गया. अब 1 correct है, 1 भी आएगा ही, C बाहर हो गया. सिर्फ 2 and 3 हो नहीं सकता. What about statement 2? Just think logically, अगर addressing scheme है, if larger address is used, then what will happen? Larger address means larger address size. इसका क्या मतलब होता है? If the address size is large, what does it mean? It implies more number of words. If more number of words are there, then definitely it will affect the processing speed. Speed will be faster. So this also affects the processing part. So this means that all of them are correct. So answer should be D. Next one, this is from compiler design. You are given with a grammar. Compiler design लगा लो, theory of computation लगा लो. What should be the answer? You are given with a grammar and you have to find out that which of the statement is not correct, which of the statement is incorrect. Answer. Analyze the grammar. You have to identify that grammar is ambiguous or not. Priority over plus, priority of plus is more than multiplication. A, that means you are saying that grammar is not ambiguous. If this statement is false, अगर आप बोल रहे हो grammar ambiguous नहीं है और ये statement गलत है, that means you are trying to say that the given grammar is ambiguous. How is it ambiguous? Ambiguity कब होती है? जब एक ही level पे multiple operations आ रहे, right? Ambiguity means if two operators are having the same priority. So are we getting the operators at the same level? No. So undoubtedly this grammar is not ambiguous. Ambiguity होती है अगर मैं कुछ instruction लिखती like t into s or s plus t something like this, तो same level पे आ रहे हैं. That means there are two ways to expand s. Though this will result into the different derivation trees, but यहाँ पे आपके पास different derivation trees नहीं बनेंगे. Are you getting this point? So this will be resulting into the ambiguous grammar. बट यहाँ पे आपके पास कोई चॉइस नहीं. एम्बिग्विटी मीन्स कंफ्यूजन क्रिएट करना, बट जब आप स्टार्ट सिंबल से स्टार्ट कर रहे हो तो आपके पास कोई चॉइस ही नहीं है, राइट? सो देयर इज नो एम्बिग्विटी. सो दिस स्टेटमेंट इज ट्रू. प्रायोरिटी ऑफ प्लस ओवर मल्टीप्लीकेशन, जब भी हम एग्जीक्यूशन करते हैं, एग्जीक्यूशन ऑलवेज स्टार्ट्स फ्रॉम बॉटम टू टॉप. right? जब आपने इसको expand किया s to t into s, something like this, and then I'm getting u plus t, and this is a, and this is b, and this is something like t, and this is s to t, t to u, u to b, t to u and u to b. ये तो एक्सपेंशन होगी. अब जब इवेल्युएशन होगी, दिस एक्सप्रेशन कम्स आउट टू बी a plus b into c into b. जब इवेल्युएशन होगी, ये वैल्यूज असाइन होगी. First value is assigned, this value is assigned, this value is assigned. So first of all, this expression will be evaluated. This means that plus is having higher priority than multiplication. जब आपके पास first term का result आएगा, t की value available होगी, तो ही आप t into s कर सकते हो, right? So this means that plus is having higher priority. पहले plus execute होगा और उसके बाद multiplication execute होगा. आपको ये expand करने की जरूरत नहीं थी. ये मैंने इसलिए expand किया because you guys might be facing a problem. तो जब भी आपको ग्रामर गिवन होती है, ऑलवेज स्टार्ट फ्रॉम द लोअर साइड. व्हाटएवर ऑपरेटर इज कमिंग अप, दैट मींस दैट इज हैविंग द हायर प्रायोरिटी, because this is the instruction that will be going under the execution first. So plus is having higher priority than multiplication, so this statement is also true. Make sense? After that, right to left evaluation of multiplication and plus will happen. अब multiplication अगर लेकर देखते हो, this is t into s. I want to expand this first, and then again we are getting this as I want to expand it further. I'll be getting here t into s, and finally यहाँ पे आपके पास u आ रहा है. U से you are getting here a, you are getting u and b. So what expression will be evaluated first? Obviously, if this is the expression a into b into a, so first of all, it's b into a that will get evaluated first. It's b into a. That means it's right to left associative. First of all, we are evaluating this expression, then it will be multiplied with a. So it is right to left. Same goes here. Here also it is right to left associative. You can see here, ये जो आप variable को expand कर रहे हो, since this is present on the right hand side, so it's right to left associative. So third statement is also true. Which of the statement is false? इनमें से तो कोई भी गलत नहीं है. So that means out of these three statements, none of the statement is false. So correct answer is it's option D. Make sense? Yes. Next question. This is from the operating system. The operating system and the other processes are protected from being modified by an already running process because the operating system and the other processes are protected from being modified by already running processes. जब भी कोई process run हो रहा होता है, it gets the limit parameters. यानी कि जो address है, address generated by the CPU is checked against the relocation and the limit parameters ताकि overlapping ना हो, right? So it's saying that they run at the different time instance and not in parallel. The statement is false. They are in different logical addresses. Logical address space is the same. This is not correct. They use a protection algorithm in the scheduler, not at all. Every address generated by the CPU is being checked against the relocation and the limit parameters. Yes, undoubtedly this statement is true. So answer for this question is it's option D. बिल्कुल basic theory के ऊपर question था. Nothing much was asked in the question. This is a good one from the compiler design. You are given with a grammar in which we have two instructions, it is saying that the number of reduction steps taken by a bottom-up parser will accept the string. Bottom-up parser hai. That means you will start from the string and finally you have to get the start symbol. You have to reach to the start symbol. So what we'll be doing is, let me take this as A. आपको string bottom up means string से start होकर start symbol पे पहुंचना है. Top down means you'll start from the start symbol. Start symbol say you have to expand it something like whatever instructions are given in the grammar, and ultimately you will come down to the string. This is the string. When you are moving in this direction, this is known as top to down. Top down. और जब आप reverse order में जा रहे हो, that means you are starting from the string and here you are performing the reduction on the alphabets of the string. यहाँ पे आप क्या करते हो? Expansion. Expand करते हो to get the string. And here in bottom up approach, we go for the reduction. Reduction. This is bottom up approach. So for this, you will be taking two strings, आप उनको combine करोगे according to the given instruction. जो भी आपको characters given है, you might be taking this, something like this. So ultimately, you have to reach to the start symbol. Here it is asking that what are the number of reduction. Obviously बात है कि bottom up में हमारे पास reduction steps आते हैं. कितने reduction steps आएंगे so that it will accept the string AAA D B. D, four reduction steps. With the four reduction steps, is it possible to reach to the start symbol? A, S, B. ना तो यहाँ पे हमारे पास S है और ना ही B है. Although हम यहाँ पे directly S ला सकते हैं क्योंकि D एक ही production में आ रहा है, that is S determines B. S determines D. So first production that I can use here is, that is S determines D. पहली reduction क्या आई? S determines D. This is the first one. बाकी सारे strings, alphabets as it is आएंगे. In the next one, in order to get the start symbol, we need A, S, B. Capital B is not there. What is this capital B representing? It is representing the small b. So I'm using here the production, that is B determines B. So this will be resulting into A, S, capital B, small b. Two reductions are already used. Now here I'm getting ASB because slowly we'll be reducing it. So ASB, now I can reduce it to S. So I'm using the third dependency as AS. S determines ASB. So this is reduced to A is coming as it is, A is coming as it is. Instead of this, we are having 7. Okay, 7 is the right answer. This is B and B. ये as it is आ रहा है, ये as it is आ रहा है. Now again, A is there, S is there, capital B is not there. So we need to use the fourth production as B determines B. So it comes out to be A, S, B, B and A. Now I can reduce it to S. Fifth, S determines A, S, B. So I'll be getting here A. Instead of this, I'll be getting S and small b. Again, sixth one, capital B. This is written as A, S, B. And now seventh step, S determines A, S, B. So finally, for this, now I'm getting S. This is the bottom up approach, and how many reductions we have used? 7 reductions are used. So correct answer for this question was option B. Clear? तो कुछ भी नहीं करना आपको reductions पे, just you are given with the rules of the grammar. You have to use it, start from the string and finally reach to the start symbol. Correct? Next one. This is again from the computer organization and architecture. Computer organization and architecture. A stack organized computer is characterized by instructions with stack organized जो computer है उसमें जो instructions use होंगी whether you'll be using the indirect addressing, direct addressing. These are the various addressing modes. Indirect addressing, direct addressing, zero addressing और index addressing. Index कहाँ पे use करते हैं array में, तो जहाँ पे something related to array is there, there will be using the index addressing. So obviously this will not be used. Any shortcut to solve the previous question? Yeah. You need not to write all these steps. Directly आप एक ही instructions लिखो, एक ही instruction लिखो A D B B B. So this is used as it is. पहली आपको लिखने की जरूरत ही नहीं है. So this will be B. Second, उसके बाद third, then fourth, then fifth, sixth, and seventh. Question finish. I need to write each and every point in detail because I'm explaining the concept to lot many learners. So सबका अलग है. Everyone is at the different level. So that's why I write each and every step. No Pradeep, it cannot be D. सबसे पहले ही हमने D को बाहर निकाला है. Index का stack से क्या लेना देना है? Just recall the functionality of the stack. In stack, we say that whatever element you want to push or pop out from the stack, no address is required. जो भी operations performed होंगे, those will be performed on top of stack. Operations are performed on टॉप ऑफ स्टैक. टॉप ऑफ स्टैक को का एड्रेस कहीं पे आपको स्टोर करवाने की जरूरत है. डेटा कहां से रीड करना है और या फिर कहां पे राइट करना है. डू यू नीड टू स्टोर द एड्रेस ऑफ दैट लोकेशन? You're welcome, Prashant. Those who are saying direct addressing or index addressing or anything, just think logically. अगर आपको stack पे कोई भी ऑपरेशन परफॉर्म करना है तो क्या आपको एड्रेस स्टोर करवाने की जरूरत है? I don't know why you guys first write the comments and then you keep on deleting it. Instead of focusing on just deleting or adding the comments, better idea is to focus on the question. So a stack organized computer is characterized by what do you think? What should be the answer? Because मुझे stack operations perform करवाने के लिए कोई address की जरूरत ही नहीं. I cannot pass the address कि भाई stack में इस particular address पे element को insert करवाओ या delete करवाओ. Insertion या deletion जो भी operation perform होगा, by default it is performed on top of stack, for which no address is required. So this means that it's the zero addressing, no address. I just need to inform the system that I want to perform the push operation. That's it. जब आप इंस्ट्रक्शन देते हो, क्या आप डेटा का एड्रेस देते हो? Do you provide any address? No, not at all. We just give the instruction like push or pop. That's it. Finish. Right? So it's the zero addressing. आप लोगों ने कोआ के सेशंस नहीं देखे होंगे. All right, now this is the question from theory of computation based on the DFA construction. Very, very important concept from theory of computation. DFA, NFA से आधा computation. जो आपके आधा सिलेबस है वो theory of computation का first unit से ही cover हो जाता है. So this is from the DFA construction. We have to return the number of states required in DFA accepting the binary strings not ending in 101. Can somebody tell me that what is the difference between DFA and the NFA? DFA और NFA में क्या difference है? 4 states. Very good. Yeah, 4 is the right answer. In DFA, for each and every input, some step is defined. Okay, and there is exactly one move defined for each and every input. That means there is no ambiguity. Each and every step is deterministic in nature. That's why this is known as deterministic finite automata. हर एक step clearly defined है. In case of NFA, that's non-deterministic finite automata. कुछ states ऐसी हो सकती हैं जहाँ पे एक input के लिए multiple ऑप्शंस आर अवेलेबल, चॉइसेस अवेलेबल. ये भी हो सकता है किसी स्टेट पे किसी इनपुट के लिए मूव डिफाइंड ही नहीं है. So this is possible in NFA, but here clearly we are given that we have to return the number of states in the DFA accepting. Wow, बहुत अच्छा डिफरेंस बताया कि एक डिटरमिनिस्टिक होता है, एक नॉन डिटरमिनिस्टिक होता है. दैट इज द फुल फॉर्म. जो आपने लिखी है वो DFA और NFA की फुल फॉर्म लिखी है. मैंने डिफरेंस पूछे, मतलब फंक्शनैलिटी में क्या डिफरेंस है. एनीवेज, जब भी आपके पास नॉट एंडिंग या इस तरीके का कुछ नॉट करके क्वेश्चन होना इन द कॉम्प्लीमेंट फॉर्म, तो इसको सॉल्व करने का इजीएस्ट तरीका है कि आप कॉम्प्लीमेंट ले लो. फर्स्ट स्टेप में व्हाट आई विल बी डूइंग इज I'll be constructing a DFA accepting the binary strings ending with 101. Although हमसे not ending with 101 पूछे, but I'll construct the DFA with I'll construct the DFA with ending with 101. After that, I'll simply take the complement of the DFA. Complement means जो आपके पास non-final states होंगे वो final states बन जाएंगे, और जो final states है those will be the non-final states. So construct a DFA accepting the string ending with 101. तो easiest approach के find out the smallest string which is accepted by this language. तो स्मॉलेस्ट स्ट्रिंग क्या होगा, एंडिंग विद 101. तो हमने ये मान लिया स्टार्टिंग में कुछ भी नहीं आ रहा, कम से कम 101 तो आ रहे. सो द मिनिमम स्ट्रिंग दैट वी आर गेटिंग इज 101. सो फॉर 101, how many states are required? If this is state Q0, this is state Q1, Q0, Q1. After that, I'm getting 1. क्या एक्सेप्ट करवाने हैं? 101. Reading 0, going to the next state. Reading 1, going to the next state. 4 states are there, and this is accepted because I want a string, I want a DFA which is accepting 101. Now this is not DFA क्योंकि हर एक स्टेट पे हर एक इनपुट के लिए मूव डिफाइन नहीं है. बाइनरी पूछा है तो ऑब्वियसली इनपुट कैन बी 0 और 1. सो नाउ यू विल एडजस्ट द एजेस. एंड पे 101 आना चाहिए. अगर स्टार्टिंग में 0 आ गया, रीड स्ट्रिंग इज स्टार्टिंग फ्रॉम 0, so what will happen? Anyhow it should end with 101, so it will not be changing its state. This will be on this state only. If will get Q0 पे 0 और 1 के लिए मूव आ गया, Q1 पे अगर 1 आता है, that means something like Q0 पे आपके पास 1 आया, you have reached to Q1, Q1 पे फिर 1 आ गया, and then you are getting 0, 1. So it will be on which state? It will remains on the same state because after that you just need 0 and 1. And here we are getting 0 and 1. So 1 is defined here. Q2 पे 1 के लिए मूव है, we need to check for 0. That means 1, 0 और उसके बाद फिर से आपके पास 0 आ गया, then we need 1. 1, 0, 1 लाने के लिए it has to go to some state जहां पे आपको 1 मिले. Because 1, 0, 0, 1 cannot be accepted. This cannot be accepted. So we need 1, 0. 0 read करके should it be going to the same state? Should it be going to Q1, Q0 or Q3, or should I take a trap state? ट्रैप तब लेते हैं जब कोई पॉसिबिलिटी नहीं है कि स्ट्रिंग एक्सेप्ट हो जाए. इसके बाद क्या आ रहा है? वी डू नॉट नो. एज ऑफ नाउ वी जस्ट गॉट 100. सो व्हाट शुड आई टेक हियर so that the string can be accepted? After this I need 101 because it has to end with 101. So 101 कहाँ से start हो क्या रहा है? Q0 से. So I'll take a edge which is going to Q0. This is for 0. Q3 पे 1 लेकर कहाँ पे आएगा? It is saying that you have got 101 और उसके बाद फिर से 1 आ रहा है. So 101 should be ending with 101. That means here we need 01, तभी आपके पास 101 बनेगा. So 01 or additional 01 is required. So it is moving to the state Q1. This is for 0. So in this case, there will be no trap state, right? This is the DFA which is accepting the strings ending with 101, but I mean not ending given tha. So I'll be taking the complement of, जब language का complement हो गया तो आपको DFA का भी complement लेना है. So here the non-final state will be becoming the final state Q0. Q1 will also be the final state. Q2 will be the final state, and Q2 will be the final state, and Q3 will be the non-final state. Remaining everything will be coming as it is. It's 1, it's 0, this is 1, and here we have 1, this is for 0, and this is for 0. And what about 0? We have not mentioned here one move. Q3 पे अगर 0 आता है, then what? If on Q3 I'm getting, this was 1. 1 आया तो 0 1 आ रहा है. This is what we had written here. Okay. Q3 पे अगर 0 आता है, it's like 1 0 1, and then you are getting 0. So after this, what is required? After this, 0 is coming up, we need just 1. So 1 कहाँ से आएगा? When you will go to Q2. So if 0 is coming up, this has to be on the state Q2. Is this clear? Now you can check from every state we have Q0 पे 0 1 के लिए move है, Q1 पे 0 1 के लिए move है, Q2 पे 0 और 1 दोनों के लिए move है, Q3 पे भी 0 1 दोनों के लिए move है. तो better है कि जो आपको given instruction है, just take the complement of that, construct the DFA, and then take the complement of the machine. Finally, you will get, now this machine will be, this DFA will be accepting the strings which are not ending with 101. Easy, simple. I guess आज के लिए इतने questions काफी हैं. Yes? Is it sufficient? जिन लोगों को DFA कंस्ट्रक्शन मुश्किल लगती है बेटा कर लो, क्योंकि गेट में भी इसके बेसिस पे काफी क्वेश्चंस पूछे जाते हैं. काफी हाई चांसेस है कि DFA कंस्ट्रक्शन पे क्वेश्चन आएगा और ISRO में भी. Do some more. Okay. Which of the following classes of languages can validate an IPv4 address in dotted decimal format? It is to be ensured that the decimal values are between 0 to 255. So will it be regular expression and higher, context-free grammar and higher, context-sensitive grammar and higher, recursive enumerable language? Context-free grammar and higher, context-sensitive grammar and higher, or recursive enumerable. Machine for regular expressions is the finite automata. For context-free grammars is the push-down automata. Context-sensitive grammars and recursive enumerable languages, that is the Turing machine. Very good. Yes. Why is it answer A? A is undoubtedly the right answer. It's the regular expression and the higher. Reason is we can construct the finite automata for any value which is finite. जहां पे आपके पास फाइनाइट आ रहा है वहां पे हम रेगुलर एक्सप्रेशन दे सकते हैं, right? Since here in the question it is clearly given that it is to be ensured that the decimal values are between 0 and 255. 0 to 255 means कुछ finite values है, infinite तो नहीं आ रहा. Since it is finite, so obviously जहां पे भी आपके पास कोई भी language, कोई भी string, anything is finite, that will be regular. So that's why the correct answer for this question is it's option A. Next one. You're given with a grammar and you have to return that what this grammar or this grammar will be generating what type of language. You're given with the instructions. This is again from theory of computation. कई बार आपको लैंग्वेज गिवन होती है, ग्रामर फाइंड करनी होती है, ग्रामर गिवन होती है, लैंग्वेज फाइंड करनी होती है. समटाइम्स यू आर गिवन विद द मशीन, डीएफए और एनएफए, यू हैव टू आइडेंटिफाई द लैंग्वेज. तो बेसिकली तीन ही चीजें होती है, लैंग्वेज, ग्रामर एंड मशीन. ओके, तो इनमें आपको कन्वर्जन आना चाहिए. S is determined as ASB or BSB or A or B. So what type of language it will be generating? All even length palindrome? Have you tried? See, इस type के questions को कैसे करने? Just try to get the strings. अगर मैं यहाँ पे strings की बात करूँ, minimum string that I can get from S is only A or B. A is possible, B is possible. If I'm taking A, this was ASA. I'm so sorry. ASA. With length 2, you are saying that all even length palindrome, that means with length 2 it is possible. Can you tell me that what string is generated by this grammar which is of length 2? 2 is an even number, right? So ASA, in order to remove this S, obviously I need to replace it with A or B. So I'll be getting either S will be replaced with A or S can be replaced with B. All odd and even length palindromes. Can you give me one palindrome which is generated by this grammar and it's of even length? If I'm choosing this one, it's BSB. S can be replaced with, यहाँ पे epsilon नहीं है. Just observe here, epsilon is not present here. You cannot take a null character. I can replace S with A or B. If I'm taking ASA, I'm replacing this with BSB, and here I'll be getting A or B. A, B, 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 A. This is possible. So this way, try generating the strings. और देखो ये किस type के strings आ रहे हैं. पहली चीज, whatever strings I'm getting, all are of odd length. There is no possibility of getting the even length string. अगर यहाँ पे एप्सिलॉन होता, अगर यहाँ पे एप्सिलॉन होता तो आप इसको एप्सिलॉन से रिप्लेस करवाते थे, तब आपके पास इवन और ऑड दोनों आते. In that case, we will be getting the answer as the option B. But since here epsilon is not given, so even length palindromes are not possible. Even length is not possible, so B cannot be the answer. Even length palindromes are not possible, so B cannot be the answer. So what is the answer? The strings that begin and end with the same symbol, जितने भी strings आप ले रहे हो सब में क्या आ रहे हैं? It's starting and ending with the same symbol. That's true. And in starting and ending with the same symbol, all odd length palindromes. This is also correct. So which one is the most appropriate answer? जब हम palindromes ले रहे हैं तो obviously बात है कि जो starting में symbol आ रहे हैं वही end से वही symbol आएगा. तो obviously बात है कि starting and ending with the same symbol will be covered under all odd length palindromes. So this is the most appropriate answer. So that's why we'll be going with the option C. Okay. So we'll end our discussion here. In the next session, we'll be taking more questions from theory of computation and the compiler design. I hope that you got the idea that जितने भी questions आए हुए हैं all are from the GATE syllabus. GATE में भी हमने ये किया हुआ है, इसी टाइप के questions आए हुए हैं and same thing is happening here. So if you have not covered the GATE syllabus, अगर आपको GATE syllabus cover नहीं किया है और आप ISRO की preparation कर रहे हो तो GATE को थोड़ा सा consider कर लो, previous year question solve कर लो, मैं भी करवा रही हूँ, आप अपने end से भी कर लो. So on daily basis we are having a session in the master class जिसमें मैं GATE के previous year questions करवा रही हूँ और जो concepts हैं वो YouTube पे चल रहे हैं. तो Monday to Friday classes होती हैं concept पे on the YouTube or questions on the masterclass. Benefit of joining this Telegram group, ये सारी की सारी information कहाँ पे मिलेगी? You will get this information. You will get this information in the Telegram group. So that is Shefali ma'am Testbook. Just go to the description of the video. You will get that link. And in this group, I'm sharing the PDF of all the YouTube sessions. चाहे वो GATE का है, चाहे वो ISRO का है. Doubts and discussion solving is there. You can directly interact with me. Quiz and polls will also be conducted. In the next session, we'll finish with the remaining questions from 2020. 19 में पेपर नहीं हुआ था क्योंकि 20 के जनवरी में हुआ था. So 18 में शायद अप्रैल के अराउंड हुआ था. So next paper that will be or the next set of questions that I'll be picking up that will be from the ISRO 2018. So this will be covering on the next week. If you guys have any doubt or query, you can write that in the chat section. Otherwise, let me discuss the schedule and we'll end our discussion. So Monday to Friday, as already I told you that I'm taking the session on the YouTube in which I'm covering the concepts of the GATE, and definitely the same concepts are there in the ISRO syllabus. 4 p.m. to 5 p.m. This is on YouTube, and in this session I'm covering the concepts. Next, at 8 p.m. to 8:30 p.m. I'm having a masterclass on the Testbook platform, which is obviously free for all of you. And in this, I'm covering the previous year questions. So you guys can join, those who are targeting on ISRO 2023, you guys can join these two sessions as well on daily basis. And deadline आपको पता है it's 14th June, तो भर लो उसको. Saturday और Sunday में ISRO के PYQs जो directly ISRO में आए हुए हैं. So I'm discussing the PYQs from ISRO. From ISRO papers. तो जो गेट वाले एस्पिरेंट्स हैं मैं उनको रिकमेंड करूंगी कि आप ये इसरो वाले क्वेश्चंस कर लो और जो इसरो वाले वो गेट वाले कर लो. ठीक है. डेडलाइन फॉर इसरो एग्जाम, डेडलाइन फॉर द एप्लीकेशन इज 14th of June 2023. सो बी फास्ट. वैसे अब तक आपका फॉर्म फिल हो जाना चाहिए था, बट अगर अभी तक फिल नहीं हुआ है सो काइंडली फिल इट आउट. It's the high time now. And age limit is, you know, that it's 28 years. Okay, this is 28 years. So this is all from my side. Anyone having any doubt? I guess no query is there, no doubt is there. So we'll end our discussion here. I guess session useful था आप लोगों के लिए. And guys, if you are attending the sessions, आपके doubts clear हो रहे हैं, आपको clarity मिल रही है, you are liking the session, तो यार video को भी like कर लिया करो. Like the video, subscribe the channel, and do join the Telegram group if you are interested to get this PDF. Okay. All right. So I'll see you tomorrow. Tomorrow is Monday. So I'll see you tomorrow at 4 p.m. with the concepts from algorithms. Currently, I'm covering the concepts of algorithms. And tomorrow, I'm going to start with a new unit that is greedy technique. Tomorrow, I'll be starting with the greedy technique. So in the next week, we will be covering the applications of greedy technique. Okay. Greedy technique is very, very important. जो questions आएंगे straight forward application based questions आते हैं. So we'll do the practice on the applications from greedy technique. Okay. Thank you so much, guys. God bless you. Bye bye. Good night.